So, hi everybody. I need to apologize beforehand. This will not be a techie talk like the wonderful talks from Philip and Thomas and so on. I will bore you a bit with higher level things, probably not with the things that you want to hear, but more the things that you need to hear in order to secure your development efforts. As you can see here, my usual domain is not classical software development, but we usually go more where things are moving, automation industry. And it's a funny thing actually that an industry that is actually known for being insecure is the one where the one international standard comes from where you can certify your secure development efforts against. So we'll talk about that. But first of all, now it's working. This is a talk about the secure development lifecycle, sometimes called SSDL, sometimes called SDLC. But what is actually a secure development lifecycle? Secure software development life, what's it about? It's not a predefined process. It's not like an additional process that you need to follow. It's not an additional process that you can take and just follow piece by piece and develop secure software. That's not what an SSDL is about. It's not even an adopted process, but usually, in most circumstances, it will be an enhancement of the software development process you already follow. So hopefully, whoever is developing software, you also have some sort of methodology, some sort of process that you are following. And this is about enhancing it with secure topics. This could be about adding additional activities in your development lifecycle, in your process, like, for example, threat modeling that we heard about yesterday. Making sure that this is really done in your projects. So really something that has not happened before if in an organization that did not take care about security yet, or at least not in an organized manner. So sometimes it's additional activities, but most of the time it actually is not even that. Very often it's just an additional content to what you already do. So for example, enhancing your already, the coding guidelines that you already apply, with security topics to make sure that it covers security. And don't do this just from time to time and a little bit, and just some team members do it and some don't. A secure development lifecycle aims to ensure that this happens all the time. So this is what this is about. Make sure security becomes an integral part of your work as a developer. Everybody who is here is obviously interested in the topic of security. So we are already the part of the developers that are security everywhere. But think about your whole organization, your colleagues, other development organization. Not everybody has the same interest and knowledge about security. And this is also what this is about. To make sure that the organization as a whole manages to develop secure software. What this is also about is to have a base for continuous improvement. We as a person can continuously improve in an unstructured way because we are motivated, we're interested in the topic, we go to sec4dev, we read books, but to continuously improve as an organization, we need something to base that on, and that is also the process that we follow. So this is also an important base for getting better over the time. Now it's working. To give you some motivation why this should actually happen, this is a very, very, very old diagram. I think there is a book from the 80s. But I still like to pick it up because this really summarizes very well why security needs to be part of the process and cannot be something that we do just from time to time or add at the very end by doing testing, what's very often happening. So what is this picture showing? It shows a diagram where we have two axes. One is the phase in which a defect is created, and this is not true only about security. This is obviously true about any kind of defect, but we focus on security here. So the first is the phase in which a defect is created, and the other one is a phase in which a defect is corrected. And the height shows the actual costs. And it shows what we actually all know, but sometimes need to remember. It is very, very, very expensive to fix a bug once a product is shipped. Especially when it's not a simple coding bug, but something that is deep inside the architecture. The product is already shipped. We need to go back to the very beginning. Maybe we need to set our requirements right, because we did not have any security validation for the requirements already. Need to re-engineer the architecture, update the design, re-implement things, ship again, updates. Very costly. So what we want to do, and what is a very important goal here, is something that we call phase containment. We want to catch security issues where they are happening. So we want to catch missing security requirements while we are in the phase of requirements engineering. Now you say, phase requirements engineering, I do agile development. I don't follow a waterfall model anymore. Still the same, right? You just do the same things at another point in time. You still need to make sure to do the right things at the right point in time. So one part of it is because we want to ship secure products, and we want to have quality, and we don't want to spend the money for firefighting, spend the resources for firefighting, but do the right things at the right point in time. There's also something that we call a technology debt, and you can also say there's something called a security debt very often, especially when we are in a new market, when we need to be the first on the market to actually get the business. Maybe we need to ship very fast, and we cannot follow a tight process. Maybe we cannot fulfill all the policies right from the beginning. And that might be fine. That might be a risk that we as an organization would like to take. But we have to consider that we are taking something that's called a security debt, meaning that at some point in time, the security bugs that we introduce will haunt us, and we will need to spend time to fix them again. Yeah? So it's nothing that we can just ignore and fire and forget and develop without security in mind. It will come back, and it will be more expensive to fix afterwards. Still, this could be a valid decision. Yeah? Take the risk, take the chances, and take the debt. Another reason to show why it's so important to have security as part of your development efforts and not as single activities. I want to discuss with you some published security issues. Those are rather old, actually, but still, for this purpose, it's good enough. So let's take, for example, a published vulnerability here, Cisco Connected Grid Network Management System SQL injection vulnerabilities. So we learned about SQL injection vulnerabilities in one of the other talks already. When you think of, for simplicity, let's take a waterfall approach. When you think of a development process, in which phase you would say something went wrong here, that this SQL injection was introduced into a product. Any suggestions? Most likely, this is a coding bug. So SQL injections usually is really about using the wrong APIs very close to the implementation and decoding. Let's take another example. Authentication vulnerability enables attackers to access SAP systems, says expert. HTTP request with modified header makes SAP login screen disappear. Very easy to use vulnerability. Which phase you would say this was introduced? Maybe it was because of a bad design, a bad architecture. Bad decisions on how to authenticate in the application. So this decision was already made before the first line of code regarding this vulnerability was created. Another example, a very famous attack. So everybody who has done a penetration test or whose organization has undertaken a penetration test usually came up at some point with paste-hash on Windows. So it's a vulnerability that's still there. It means that Windows has a very bad vulnerability actually regarding single sign-on mechanisms, and to stay compliant, this vulnerability exists for decades now and still is valid in newest shipped operation versions. So this was most likely, yeah, maybe a failure in requirements engineering, or at latest, bad architecture choice to do things that way. So different phase. What we have here, worldwide map of internet-connected SCADA systems. We see that happen from time to time, systems that are not so much self-defending, but more depend on the protection of the network, are connected to the internet. Most likely more a mistake by the operator, not the developer itself. So what I want to show here is that throughout the development lifecycle, there are different mistakes that we can make, different vulnerabilities that we can introduce. We can introduce vulnerabilities by missing certain security requirements. And if we have missing security requirements, not the best code review in the world would mitigate that. So we need to check the requirements engineering in this case. We need to validate our requirements. So what we need to do is we need to make sure that in all the phases of our development, we set the right activities to make sure that we build security into our products. And what are those activities? I want to show a scheme, and this scheme actually gets us closer to where I want to get, and that is a standard that we actually can use to know what security activities, what security practices are actually expected from an organization that is building and shipping secure products. So let's start at the beginning of a simplified development process with the specification. What is it that needs to happen there? And as I said before, usually this is not a separate process that is happening here, not a security process next to your development process, but those are practices and content that are added to whatever is the process that you find most suitable for your organization. First of all, like other requirements, we need to consider also security market requirements. What is it? Where are we shipping to? Do we have to follow certain regulations? If you have a product and you plan to ship your product, for example, to the energy domain, you need to follow certain standards to do that. If you want to have a product that is used also together with medical devices or as part of medical devices, for sure you need to follow certain requirements and maybe even need to have them certified. So we need to identify what are the applicable market requirements. What we also need to do, and I will get closer to that later, we need to define the security context. Think back to what Lucas said before about liability issues. If we don't define what this product is intended to do and in which domain, which environment it is intended to be used, this could be a liability issue. So that's one reason to set and define and write down. And that's the important point every time we talk about processes, right? We are writing things down. We don't just think about it in our heads, discuss it at a coffee, but we actually write things down and define it. A product security context is liability. We'll get to this and see other reasons why this is a very good idea to do. We define security requirements. This could be part of the market requirements. This could be internal security requirements that we use. This could be, unfortunately, this is hardly ever happening. This could be concrete security requirements from our customers. So hands up, who is getting concrete security requirements from their customers? One? A few, right? Usually we just have one security requirement from our customer, and this is we expect the product to be secure. Whatever that means, right? So ideally, the customers would set the security requirements. They don't. They expect us to design and build the product in a secure way and define what secure means. And one thing that supports this is the famous threat modeling. So we always get back to threat modeling. It is a very important part. It guides your development. It guides what security actually means for your product. What is a threat to your product and what is not a threat to your product. For some products, privacy is a very, very big issue. For other products, it might be a non-issue. It might not be a requirement at all. So that might be very different. So ideally, we set the right security requirements by observing what is asked from us, and on top of that, by doing threat modeling and see what we need to do to get a secure product. What are the requirements? What is also necessary? We go one step further in the development. And again, here, this is a very linear process. This could be any kind of development approach. This doesn't have to be step by step. This could be iterations. This could be agile. What we also need to consider is then, of course, the design. Sometimes you have discussions, what is actually different between a security principle or security requirements for my architecture and a security requirement. In my opinion, it's a very academic discussion. So it's pretty much the same thing. Define secure design principles that need to be observed and secure design best practices. Things that we define as an organization that are requirements to our architectures, to our designs. What could that be? What are examples for that? This could be principles like least privilege. This could be principles like defense in depth, so very high-level things often. And that's probably what makes it different from security requirements. And of course, a very important part of all of that is that we do the right things, but then also check if we have done the right things. So reviews, like always with quality management, is an important part of making sure that we are building and shipping a secure product. And this means not just the review at the very end of the product development, but this means the right review mechanisms in every phase of the development lifecycle. Once the design is done, we go to implementation in a linear process, and then you see some very obvious things that we are used to do. The question is, how mature are we applying those things? And how mature are we reviewing those things, and how mature is the security part of those things? And when I say those things, I'm talking, for example, about coding standards. I'm pretty sure that pretty much everybody in this room is applying coding standards in one or the other form. Usually it's not done anymore like in the past where you had actually your secure, your coding guidelines printed out maybe, or if a book, if a distinct document. Very often now it's wiki pages, it's integrated in tools, etc. But you will have some kind of coding guidelines. Very often, in the organizations that I see, those are very limited to things like style guides, like how to use APIs, not regarding security, but how to form our code to make it maintainable, for example. And of course, we need to make sure that also security aspects are considered there. So very often the base is already there, and this is where I say many companies have a good base, but need to move forward to also include security in those things. Then again, there are of course reviews. We do security testing. I will talk about that a little bit. And what is a big gap usually, and that is something that most organizations neglect to a big extent, is actually that also guidelines are a product of development. So actually when we ship a product and we develop a product, we don't just produce the code and the actual application, but we neglect that part of it, what we develop, is also the documentation to it. And there are certain things that should be part of the documentation regarding security. And we will have a look at that as well. And security testing, of course, is an important part, because even though we try to do the right things at the right moment in time, we know at some point we will fail. We are not perfect. We make mistakes. So security testing obviously is also an important part to make sure we achieve the right level of security. So now I would say the product is tested, it's shipped, our security obligations are done. That's not the case. We are talking about security development lifecycle, product lifecycle. there are things that we need to do and need to be prepared for even after the product is shipped, or maybe is running as a cloud application. And there are two things that I picked out here. One thing is vulnerability handling, meaning that even though we test it and produce a secure product, most likely vulnerabilities will be found in the product at some point in time. And we need to have a way to deal with these vulnerabilities. We need to deal with the person who is reporting a vulnerability. We need to be able to find the development team. Maybe at that point in time, the development team is not in place anymore for this project. The people are working on new projects, so we need to be able to identify who can actually analyze and fix this vulnerability, and we need to be able to ship a patch for it. That's vulnerability handling and patch management. So secure development lifecycle does not end when we ship the product. And this is the overview of what we consider a secure development lifecycle. Probably not a totally complete overview, but it gives a good picture of what are the most important points there. And then I hit something here at the bottom. This is very, very tiny and seems like a very little thing because it's outside development, but actually this is where most organizations struggle with and have the largest gaps also regarding certification, and that's what we call security management. It's all those things that the organization needs to provide for the project so that the project actually can do their job and produce a secure product. We'll get into that in more detail, what's in there. But before we get to those details, where is this actually coming from? We're talking about certification. There's a certain standard, and it's called IEC 62443. And actually, the IEC 62443 is for a certain domain, which is industry automation and control systems. And what is that? It's probably all those things that actually brought you here to this conference. It's, for example, special equipment that is used in energy generation and distribution. Very specialized equipment. It is, okay, that was a bit fast. It is the equipment that controls, for example, water supply. It's also the equipment that controls wastewater. It's the equipment that keeps factories running and is used to actually control production machines. And it is also what is used in infrastructure. So this is actually the target of this IEC 62443. Not the classical office IT equipment, but those very specialized piece of products that includes hardware as well as software. And this is what actually looks like. So for somebody who hasn't seen it yet, it's a bit small here. This is very specialized hardware with certain characteristics, but at the end, it also runs software. Very often quite proprietary software, very often quite old software, very often software that you would not necessarily consider secure. And this is also why the standard was created. And now I throw the whole standard at you, where actually most things are not relevant for you unless you are working in this domain. So the standard consists of several parts that we don't want to learn right now. What's very interesting is that it is divided in security requirements regarding the operator, which means the users of the systems. So for example, energy distribution providers. Security requirements towards those who build the larger systems. So for example, those companies that build whole trains. And then we have the last part, and this is actually what's interesting for us, are those parts that are targeted towards the vendor. Vendor meaning the organization that is creating and shipping the components. And here we have two parts. One is called the -4-1 and one is called the -4-2. So whoever is used to work with standards and certifications, you're used to work with those numbers. For anybody who is not used to that, it's a number nightmare. So in standardization, you get numbers thrown at you all the time, and you're supposed to know what regulation this is. So here we call it just the 62443-4-1. And what's very interesting is that here they define what is necessary to do in a secure development life cycle. So the original target was actually the industrial automation domain. And most of these parts are actually only interesting for you if you are working in the industrial automation domain, but especially this -4-1 is actually quite independent from whatever product you are developing. It just defines expectations, practices to develop secure products. The nice thing is, if this is of interest for you, this is possible to certify. So this is the only way, or one of the very few ways, there are some not so much used exceptions, to get an official certification of your secure development practices. So what's part of it? A very big principle of it is what we call defense in depth. Defense in depth on different layers. When we talk about the secure design principles or the secure development, it is about not relying on a single activity that we do in development. A lot of companies that we see are relying regarding security on testing. So we do development, we make our architecture, we implement, and 2 weeks before shipping, somebody thinks about, oh, maybe before we ship it, we should have a security test. Does that sound familiar to some of you? I heard it happened. So what we want to achieve and what this standardization wants to achieve is that this is not the case, that we don't rely on a single activity like testing to ship a secure product. This is not working, obviously, unless you have very extensive testing, but this is not very suitable. So what we strive to do here is to do the right things at the right moment in time and also prepared that after we shipped the product to react in the right way. So, and then, the standard is divided in different practices. I will go into details of all those practices because we'll fall asleep very easily then. But this gives you an overview of what this is about. This is pretty much what we saw before in the process. So it defines requirements regarding the security management, and then we go into the process, specification of security requirements, the design, implementation, verification, validation, testing. And then we have some additional processes, how to deal with defects, management of security-related issues, security update management, security guidelines is about the documentation. So those are the things that you've seen before. And in all of these practices, there are several requirements, give you a bit more specifics on what to do there actually. But don't expect too much. It still is a standard. It will never tell you how to do something. This is both good and bad. It is bad because if you're looking for guidance on how to do code reviews, you will not get it out of the standard. But it is good because it leaves it up to you to select what is the right way of, for example, doing secure coding. What is the right way of doing code reviews? There are many ways to do it. There are many ways on, there are also many points in time in your process when to do it. The standard will never tell you those details and never require you to follow something very specific here. I said that many organizations are struggling in the picture of security management because this is something that, especially from a developer perspective, this is something that is very often not visible. But if your project, for example, you feel that your project is struggling with security and you don't know quite why, maybe the answer is that there are gaps in the security management. So let's see what's in there. The actually very first requirement from the standard is that you must have a reliable software development process. This first requirement does not talk about security at all. It just says, actually, before we can start discussing security topics in the development process, you need to have a reliable development process at all. Whatever the process is, It does not have to be waterfall, it doesn't have to be agile, it can be anything that is suitable for you, but the requirement is that it needs to be a reliable process, that it gives you certain capabilities, like for example, to track and make sure that you fulfill the defined requirements. We do those gap analysis, and especially in the industry domain and probably also other domains, many development organizations are right now shifting from, I say, a more linear process to a more agile approach. And then I ask them, okay, how do you make sure that you have the right requirements and that you track the requirements and make sure that the requirements are actually implemented in your product and they are tested? Is it the camera? Then I hear the answer, but we are developing Agile now. We're following the Agile manifest. We don't do any documentation anymore. We have user stories. Those user stories are implemented, and once they're implemented, we forget them. Okay. This is a very bad approach for doing Agile development. Yeah? Agile development is not about, I don't need to document anything anymore. And you would actually miss this very first requirement here. So we will never start talking about any security things. The development process on its as a whole is not working sufficiently. And then we get to some very interesting things. And think about your organizations if you have that. And one of those practices is and requirements is identification of responsibilities. Who is responsible for security in your organization? Who is responsible for shipping secure products? For different aspects of this, we'll get into that. Identification of applicability. This means which product is the secure development lifecycle actually applied to. Not necessarily all your products need to have the same level of security. Maybe some products don't need to have any security at all. Maybe some need to be Fort Knox. You need to have a way to identify that. You don't just need to have the roles defined, you also need to have the right expertise. So think about, in your project teams, do you have the right knowledge to build and ship secure products? And do you have it coincidentally? Because in your project there are enough people that have interest in security? Or is it done in an organized way, and does the organization make sure that this knowledge is available to the extent needed in all the projects? That's the difference here. Process scoping, meaning that not necessarily all of the activities that we've seen here are done in the same way in all your projects. Maybe some projects just need a, let's say, less effort in doing security testing because it's not used in a high-risk environment. And other products need a very deep penetration test. File integrity, this is about providing the customers the capability to ensure whatever you ship them is actually coming from you and not from a rogue third party. That happens. We've seen active attacks on that. We've seen, for example, in the energy domain that vendor websites have been hacked and the update mechanism has been manipulated so that actually energy transmission organization would download malicious software from the original vendor website. This can be mitigated to some extent with file integrity. Then we have requirements regarding development environment security. This is about the machines that you're developing on. This is about your IT department annoying you that you should have less rights on the machines that you're developing on. Probably something that you have experienced. This is about making sure that not everybody in the organization can change our Git repository. Control of private keys, and so on. So I want to get to some things in more detail. Regarding roles, I want to make you think about two different kind of roles. First is, first is what are security expectations and what roles do you have already in your organization like typical development roles, like developers, like architects. And what are their responsibilities? So this is part of the roles here. So for example, the project manager needs to make sure that the security tasks are actually executed. Testers need to write and verify security tests. But you also need to think about, maybe in my organization I need to have additional roles, particularly for security. That is not a very concrete requirement from the standard, so you can do it without. If you say, I don't need that, I can have my developers trained and they have the experience and responsibility. But very often we see that it's a good idea to have 2 or 3 different roles. One is something you can call product security officer, so more a strategic role. Other is security expert, which is more the people in the project who have the technical expertise and are the go-to point regarding security. And a central team, maybe, especially in more mature organizations, where you bundle your security expertise and have a central point for security that projects can rely on. So I need to go faster, much faster. I don't have 77 slides, but still. One important point, and I will not discuss it because it has been discussed in many other talks, and it is also a very crucial point in this standard, is that you need to take care of everything that is part of your product, and this doesn't include only what you're coding, but all kind of libraries that you include. Think about who is responsible in your organization, who is allowed to include third-party libraries in your code, and how is it shipped. Who is making this decision? Is every single developer allowed to say, I need a certain mechanism, I found a library on GitHub, I will include it? Who is testing it? Who is making sure that this is not a Trojan? Who is making that sure that it has the right quality? You need to do that. Same thing if you have custom developed for you. If you outsource development, you need to make sure and you're responsible that this development is also following your security practices. Security context, we talked about this already. That it's important about liability. And this is a very important piece of documentation. You document your assumptions. We all make assumptions, but who of you has actually written down your assumptions about your product environment, the way that it is used at the customer, and especially about the security expectations there? I hardly see that. It's very important to write those assumptions down, to verify those assumptions, and to make those assumptions also part of your product documentation. Make your customers know about those assumptions, and ask your product management if you can still ship your product if you write down those assumptions. Because if your assumptions in the way that you develop is that a product is only used offline with a single user and not connected to anything, your product management might say, well, we cannot sell this product anymore. So we need to change these assumptions and change risk evaluations. Okay, I need to pick out what I see very important here because time is running very fast. We talked about automation and testing already. This is a very crucial point to get success here. Do the testing, try to automate security testing and learn from the manual testing. You always will need also to add manual testing because this is where you learn and find new things, but after you learn them, you need to automate it. I'm jumping here a bit. You will find more information in the slides. I want to give you actually, and I lied to you, I have a slide with code. I will show it to you in the break. What I want to show you is certifications. Actually, this should be about certificate. This is actually one of the few ways to get actually an external certification of your secure development practices. You can do it in 2 ways. Either you can have certified your process alone, your organization, the way that you develop, so pure process certification, or you can also have a certification for your process applied to a particular product and also certify that this product is fulfilling certain functional security requirements. Who is doing those certifications? Accredited bodies, like in Germany, for example, the different TÜVs, DEKRA. So everything, companies that have an official accreditation for doing international certification. So it's a very nice thing. Even if you don't go for certification, it's still a nice thing to look into those standards because it tells you what the community in general is expecting from a security development effort. Okay, and obviously there are much more things to say that I don't have time to say. If you want to go that direction, if you haven't already done, I want to give you a last tip. You need to set it up as a project. Experience shows that this is nothing that can be done in addition by somebody who is currently interested in the topic. Those organizations that succeed in doing it usually set it up as a project, have somebody responsible, have resources assigned, and take everybody aboard. So not do it from outside, but actually talk with the developers, talk with the testers, talk with product management to make sure this can succeed in the organization. Okay. This was the overview. I'm sorry that I didn't have time to go into more detail for some topics, but I'm here until the end of the event.
Cool.
And we'll have time now, I think, for a few questions.
Please approach Peter. So if you have any further questions apart from those that we're going to ask now, we have 2 minutes for a couple of questions. So first one, how does ISO 27001 overlap with ISO IEC 62443? Could the latter be seen as some sort of specialization on certain ISO 27001 processes?
Yes, especially at one, because 27000 also requires you to take care of the risks in the products that you develop, but only to a very tiny bit. There are not many details. So it's very good to use both things. They don't overlap too much. We've seen here we have one requirement about the secure development environment. That is very typical ISO 27000. And in ISO 27000 you will see a single requirement about taking care of the risks about the products you development. Here the 62443 is much stronger. So I recommend use both. They have a different scope.
Is there a rough mapping between EC 62443 and OWASP SAM? Which maturity level would a certified process have at least?
I don't know of any kind of mapping. You have certain freedom also to choose and make sure that you select those activities that make sense for your organization. So 62443-4-1 does not work with the maturity levels. You could do a mapping, and I also encourage you, if you strive to implement 62443, to look into resources like OWASP, but I'm not aware of any direct mapping that maybe even an auditor would accept.
Okay, so one last question. You mentioned threat modeling in the design process. So how do you suggest to scale threat modeling in an agile environment with hundreds of developers?
Good question. I think we had the same question yesterday already. If you are an organization that needs to deliver fast and to deliver often, you need to have the right processes in place. And threat modeling should be the one thing that you do on top. You don't do it for every feature and every detail, but you need to make sure that you have like a very clear definition of which frameworks you use in the organization, how to use those frameworks, which coding guidelines to do. So to have the right things in place without doing something that is work-intensive like threat modeling and still have a high confidence in what you're shipping. And then on certain points in time, or let's say for a major release, you do the threat modeling and repeat it from time to time, but obviously you cannot do it in, what did we say yesterday, if you ship every half hour or deploy every half hour, you cannot do threat modeling for that. But you need to have the processes in place to still have confidence that you're shipping the right thing without doing threat modeling for every little detail. So to use TLS, you should not need to do threat modeling to do that. That should be part of your normal development behaviors.
Thank you very much.
Thank you.
Thank you.